Today, we are going to be checking the effects of cutting height. Let's understand the effect of cutting height and then see some examples. If we look at the picture, we can see that the plasmark is shaped like an oval. On the left side, we can see an illustration of the torch cutting the same plate in different distances. If the distance to the plate is small, the closest part of the arc in relation to the torch is doing the cutting. This creates negative bevel, meaning the top surface is bigger than the bottom surface. Too small cutting height is also prone to collisions. When the distance is optimal, the plasma cuts with a middle section of the arc. This gives you the optimal cutting angle. If the distance to the plate is long, the farthest part of the arc in relation to the torch is doing the cutting. This creates positive bevel, meaning the top surface is smaller than the bottom surface. When the cut height gets high enough, the arc will not be able to cut through the plate anymore. In the video, you can see the torch almost touching the plate while cutting. You see the spray of molten metal shoot towards to the direction of travel. This creates a negative cutting angle. In the next video, you can see the torch cutting at the correct height. You see the spray of molten metal shoot straight down. This results in the best cutting angle. Here we can see the torch cut with a too high cutting height. You see the spray of molten metal shoot backwards from the direction of travel. This creates a positive cutting angle. Thank you for watching, and I hope to see you in the next video.